motor nameplate indicates 25 horsepower, 74 amps, 208 volts, 3-phase, service factor of 1.15, code F, design B, table 430.250 of the 2005 National Electric Code provides a full load current of 74.8 amps. Therefore, the circuit conductor ampacity is calculated by multiplying 74.8 amps by 1.25, resulting in 93.5 amps. To size the circuit conductors, use the calculated value of 93.5 amps. For overcurrent protection using an inverse time breaker, multiply the full load current of 74.8 amps by 2.5, resulting in 187 amps. The next higher standard breaker size is 200 amps. The National Electrical Code requires locked rotor amps, or LRA, to be considered when determining the circuit conductor ampacity if the motor has a code letter of E or F and a design letter of A or B. In this case, the motor has a code letter of F and a design letter of B. The circuit conductors are sized for 93.5 amps. The overcurrent protection is set to 200 amps using an inverse time breaker. LRA is not required to be considered in these calculations. Additional notes: firstly, the 1.25 service factor is applied because the motor has a service factor of 1.15, which is less than 1. Secondly, the inverse time breaker multiplier of 2.5 is used because the breaker will trip after a certain time delay when the current exceeds its rated value. Thirdly, the next higher setting for the breaker is 200 amps, which is acceptable because it provides adequate overcurrent protection without tripping unnecessarily. The motor full load amps, or FLAW, from the NEC table is multiplied by 1.25 to account for the service factor. The result of this calculation is then used to determine the minimum ampacity of the conductors that will supply power to the motor. Overcurrent protection is determined by multiplying the motor's full load amps by a factor determined by the type of overcurrent protection device being used. For inverse time circuit breakers, the multiplier is typically 2.5. The locked rotor amps, or LRA, is the current that the motor draws when it is first started. This current can be significantly higher than the motor's full load amps. The NEC requires that the circuit conductors and overcurrent protection devices be sized to handle the motor's locked rotor amps under certain conditions. If a motor has a code letter of E or F and a design letter of R or B, then the locked rotor amps must be considered. Motors are designed differently. Designer motors have normal starting torque and starting current and slip. Design B motors have normal starting torque, low starting current, and low slip. Design C motors have high starting torque, low starting current, and low slip. Design D motors have high starting torque, high slip, and are used for applications requiring high breakaway torque. Motor code letters indicate the locked rotor kilovolt amps per horsepower. The code letter can be found on the motor nameplate. The code letter is used to determine the locked rotor current of the motor. The NEC provides tables that list the maximum locked rotor current for different code letters. To properly size a motor circuit, firstly determine the motor full load amps, or FLAW, from the motor nameplate or NEC table 430.250. Secondly, multiply the FL8 by 1.25 if the motor has a service factor of 1.15 or higher, or a temperature rise of 40 degrees Celsius or less. Thirdly, determine the minimum conductor ampacity by selecting conductors with an ampacity equal to or greater than the adjusted FLA. Fourthly, determine the motor locked rotor amps, or LRA, from the motor nameplate or NEC tables. Fifthly, select an overcurrent protection device based on the LRA and the type of motor. Finally, verify that the selected conductors and overcurrent protection device meet all applicable NEC requirements. The motor's service factor is a multiplier that indicates the motor's ability to handle brief overloads without overheating. If a motor has a service factor greater than 1, the motor can handle occasional overloads. The overcurrent protection device is designed to protect the motor and circuit conductors from overcurrents caused by short circuits or ground faults. The overcurrent protection device should be sized to allow the motor to start and run without tripping unnecessarily, but also to protect the motor and conductors from damage due to overcurrents. Conductor ampacity is the maximum current, in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacities of different types of conductors under various conditions. Motor circuits require careful consideration of conductor ampacity and overcurrent protection to ensure safe and reliable operation. The locked rotor amps, or LRA, is the current drawn by a motor when it is initially energized but the rotor is not yet turning. This current is significantly higher than the motor's running current and can last for a short period, typically a few seconds. The LRA value is crucial for sizing overcurrent protection devices to prevent nuisance tripping during motor startup. The National Electrical Code, or NEC, provides guidelines for calculating motor circuit ampacity. These guidelines take into account the motor's full load current, service factor, and temperature rise. The NEC also specifies the types of overcurrent protection devices that are suitable for use in motor circuits. An inverse time breaker is a type of overcurrent protection device that trips faster as the current increases. This type of breaker is commonly used in motor circuits because it can handle the high inrush current during motor startup while still providing protection against overloads and short circuits. The multiplier used to determine the trip current of an inverse time breaker is typically 2.5 times the motor's full load current. The next higher standard breaker size is allowed if the calculated trip current does not match a standard breaker size. This allows for some flexibility in selecting the overcurrent protection device while still ensuring adequate protection. Motor design letters, such as MP, indicate the motor's torque and current characteristics. These characteristics are important for selecting the appropriate motor for a particular application. The design letter also affects the way the motor circuit is calculated and protected. The code letter on a motor nameplate indicates the locked rotor kilovolt per horsepower. This information is used to determine the motor's locked rotor current, which is essential for sizing overcurrent protection devices. The service factor of a motor is a multiplier that indicates the motor's ability to handle brief overloads without overheating. A service factor of 1.15 means that the motor can handle a 15% overload for a short period. When calculating motor circuit ampacity, the service factor is used to increase the motor's full load current to account for potential overloads. Temperature rise is another factor that affects the ampacity of conductors. As the temperature of a conductor increases, its ampacity decreases. The NEC provides tables that list the ampacities of conductors at different temperatures. When selecting conductors for a motor circuit, it is important to consider the ambient temperature and the conductor's temperature rating to ensure that the conductors can handle the expected current. The motor full load current, or FLO, is the current that the motor draws when it is operating at its rated horsepower and voltage. The FLA is used as the basis for calculating motor circuit ampacity and overcurrent protection. The FLA can be found in the motor nameplate or in NEC tables. When calculating motor circuit ampacity, it is important to consider all relevant factors, including the motor's full load current, service factor, temperature rise, and locked rotor current. The NEC provides detailed guidelines for calculating motor circuit ampacity and overcurrent protection to ensure safe and reliable operation. Understanding these guidelines is essential for anyone who works with motor circuits. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes for the most up-to-date requirements. Safe electrical practices are paramount to protect people and property from electrical hazards. Always work with qualified and licensed electricians for any electrical work. Electrical safety is no accident. It requires knowledge, skill, and a commitment to following established safety procedures. Be sure to disconnect power before working on electrical circuits, use appropriate personal protective equipment, and never work on live electrical equipment. Electrical hazards can be deadly. Taking precautions and following safe work practices can prevent accidents and injuries. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying informed about the latest changes is essential for electrical professionals to ensure that their work meets the highest standards of safety and quality. Continuous learning and professional development are key to maintaining competency in the electrical field. By staying up to date with the latest codes, standards, and technologies, electrical professionals can provide safe and reliable electrical services to their clients. The information provided in this narration is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified and licensed electrician for any electrical work or questions. The content is based on the 2005 National Electrical Code. Subsequent versions of the NEC may contain different requirements. Be sure to consult the latest edition of the NEC and any applicable local codes for the most up-to-date information. Locked rotor amps, or LRA considerations, are an important aspect of motor circuit design and protection. Understanding when to consider LRA and how to properly calculate motor circuit ampacity and overcurrent protection is essential for ensuring safe and reliable motor operation. By following the guidelines provided in the National Electrical Code and consulting with qualified electrical professionals, you can ensure that your motor circuits are properly designed and protected. This helps to prevent electrical hazards and maintain the integrity of your electrical systems. Remember that electrical safety is a shared responsibility. By working together and following established safety practices, we can create a safer environment for everyone.